Alright guys, today I want to show you how to do KKTM font. It's like a keychain. So first, go to the text and drag in the middle, and another text exactly in the middle. Alright, then go to the text too. Go to text and type KKTM. This lay down. And for text one is KKTM. Alright, for size for KKTM font, we choose anchor. Then for KKTM, the font is Pacifico. We type Pacifico. Alright, after that, so it should be like this. Then for text one, we go to the letter spacing. The letter spacing is negative 0.13. Wait. Alright, after that we go to the show more option for KKTM, and we type letter spacing is negative 0.13. 0.13. Right, so it should be like this. Then for redang, same, 0.13 for the letter spacing. After that we do this dengan KTM font. Alright, then we highlight the KKTM ledang. Then we go to the modify. We go to the outline stroke. Then after the outline stroke, the width is 0.8. Then we highlight again. The KKTM ledang. We go to the modify, and we choose the border union well. will be like this. Then after that, after we done the KKTM redang, we go to the file and save into the export.xf. Then type mini project. Then download. After that, we go to the new tab and we type the on shape and we log in the on shape, sign in. Then we go to the create and we choose the folder, we choose the document and we type mini project. And we create. Wait for the moment. Alright, after that we right click, we highlight this all and we go to the new sketch. Just the front. Alright, so after that we go to the DSS folder, we import, we enter our mini project. Wait for the download. We go X and we insert the mini project into the on shape. So it will be like this. Then when we highlight the border, all the border. After we highlight the border, all the border, we go to the extrude, and for the depth we go to the 0.8 millimeter. After that we write. After that we go to the sketch again and we create the new border to put the kitchen. Wait. We create the border. Then after that we trim the line we do not. So it should be like this. Then after that we we highlight the out border and we extrude. We go to the opposite direction and click, and this is 35 minutes. That we go to the sketch. Alright, after that we go to the sketch again, and we click the in border. Then we extrude again, and we click the opposite direction. And starting offset we set 1 mm. Alright, it will be like this. Now we want to remove at the background to add the PCB layout. Then we go to the sketch again. And after that we extrude this again. We highlight this. Now we extrude. Fold this. We try so it should not go be like this. Then we go to the finish it to buang. So it's gonna be like this. keychain on there. Yeah. Right. So we done our mini project. So that's all for me. Thank you.
Hi everyone, my name is Qistina design. So today I will make an explanation for task 2, which is a PCB layout. The first thing, we must do a schematic circuit. To do a schematic circuit, we must create a new project. So we must open a Proteus and then go to the file, click a new project, and then give it a name and select the paste to save. And then we have to choose a schematic capture and PCB layout option because we must do a PCB layout. And then for a schematic design, we have to open a schematic capture tab and then place a component. How to place a component? We have to click on the P is pick device, add a component like resistor, capacitor, transistor, IC, then connector that we must use. And then wire the circuit of them, the component. We must wire them. Use the wire tools to connect the pin of a component as per your circuit design. So here the step how I put a component and click the wire step by step. This circuit uses a 55 IC powered by a CR1220 coin cell battery. To control the blinking of the LED, the 55 timer is set in ensemble mode, which means it's continuously switched in output and on and off without needing any external trigger. This on-off action fitting a pulsing signal at pin 3 of the IC. The blinking speed is controlled by two resistors, which is R1 and R2, and capacitor C1. So this component determines how fast the output change between the high and lower. When the output from pin 3 goes high, it sends a signal to resistor R3 to a transistor Q1, which acts like a switch. When the transistor turns on, it allows a current to flow to the LED through the resistance R3 and RC, causing the LED to light up. When the signal from the timer goes low and transistor turn off, and the LED turn off as well. This is also connected for temperature sensor, which may be used to influence the circuit depends on the sensor readings. But its full function is not clear in this diagram. Overall, this is a simple LED blinking circuit using a 5-watt timer and a few resistor and capacitor, transistor, and a small battery. That's the component that we use is that's yang I already said. So for another step is to do a PCB layout. So you must switch to the PCB layout mode. Click on the PCB layout tabs and then use the component mode to place your component on the PCB canvas. But before that, we must do a board X. Use the board X tool to draw the yellow boundary for the boards, and then put the component in the board, in the yellow boards. Okay, after we put all the components on a PCB layout, we must do a rotor PCB on manual routing. So the first thing is select the track mode tools. Choose the top copper reds and bottom copper blue for routings. Click and drag from one page to another to route the tracks. And then use a tool and then choose a auto rotor for automatic track generation. And then lastly, we must verify a design. Click on the DRC, which is Design Rules Checks, tools to detect layout error. So lastly, I will show you guys the result of 3D PCB design. So here the example of the design on this Proteus. Okay, so this is our last task, which is task 3. So in task 3 is the last step before we print our 3D design. We take the STL file from Onshape and open it in slicing software, which is Ultimaker Cura. Did you guys know what is Ultimaker Cura? Don't know, right? Okay. Ultimaker Cura is a program that prepares 3D model from printing. It changes the STL file into a G-code, which tells the 3D printer how to print the object. In Cura, we can change settings like layer height, print speed, temperature, and more. In this step, we also need to rotate or flip the model. We put the flat side on the bottom and the detail side on the tops. We do this because of putting the flat in the side of bottom helps the model stick better to the printer beds. If the detail side is at the bottom, the model might not print properly. We also need to add support for parts that are higher or not touch the beds. Support is important so the print does not fall or break. When everything is ready, we save the file as G-code. Then we can start printing in the it with the 3D printer. So that's all. So I will show you guys the outcome of our project in the last video. Thank you.
project.